Topics in Math 1.2 Part 1, Definition of Radical to Exponential Form, Properties of Exponents, and Simplifying Radicals. Let's go ahead and get started with a warm-up problem from last week. Think about this original answer as your x. Feel free to pause the video if you already know how to do this or if you remember. But we want to rewrite this repeating decimal as a fraction. So go ahead and pause the video and work on it. All right, so we needed to take the value since it was repeating one spot here. I'm going to write, think of that as 5, 5, 5. We needed to multiply that by some number so that it still has those 5 show up. So what we can do is multiply that second equation times 10. So that's just going to move that decimal over one spot. So it's still going to have all those 5s. It's just move the decimal over a spot. And then what we can do is subtract. So 10x minus 1x, that'd be 9x. All the 5s, 5 minus 5 is 0. So all the 5s cancel out except for this first one because that wasn't 5 minus 5, that was 5 minus 3. Okay, so we get 9x equals 21.2. So use your algebra skills to finish this. So we're multiplying, we need to undo that and divide. So we get 21.9 over 2, 21.2 over 9. That is not written as a proper fraction because you can't have a decimal in a fraction. So we need to move that decimal point over so that it's 212 over 90. Okay, and then finally we can divide by 2. Okay, so 2.35 repeating is the same thing as 106 divided by 45. You can check with your calculator by taking 106 divided by 45. All right, couple terms here. We're going to go from radical form to exponential and vice versa. Okay, so let's look at a couple other properties. Remember, anything to the 0 power is 1, and if you have a negative exponent, we want to make it positive. We can move it to the denominator. All right, so if we want to put these into radical form, so if it was a to the m over n, we can rewrite that as the nth root of a to the m. So in this case, we'll have the square root of 8 to the first. Now square root of 8, we can simplify that. So think of the perfect square. 1 squared is 1. 2 squared is 4, 9, 16, 25. Which one of those divides evenly into 8? It would be the 4. So we can break that apart. Square root of 4 times square root of 2. Okay, so 8 to the 1/2 power, we can simplify it to be 2 times the square root of 2. The second one, we're not going to simplify all the way down because we can't have a fraction exponent in the denominator or radicals, but we can rewrite this as a radical. So the cubed root of 6 squared, we're just going to stop there. Tomorrow we'll expand on this. All right, the 5th root of n to the 3rd. What if we went the other way around? So this is going to stay there, so x to the 6th. Where does that 4 come into play? That's your denominator. Okay, so remember if we had the nth root of a to the m, that's the same thing as a to the m over n. Okay, so 6 over 4, don't forget to simplify if you can. So we get x to the 3 over 2. Okay, number 5, we can rewrite that as x to the, remember, if there's no exponent, it's like a 1. So x to the 1/3. If we wanted to put it up in the top, it would be x to the negative 1/3. And then finally, we can rewrite this one. Remember, just leave the original problem how it was, x to the 7th. And that index becomes the denominator of your fraction exponent. Okay, we talked about some of this last week, but if you are multiplying exponents, and that have the same, so same base, a to the m times a to the n, you're going to add those. Whereas if you are taking an exponent to an exponent, like you are down here, you're going to multiply those. Okay, over here we've got dividing. What we can do is subtract. Our exponents, this one we're going to apply the exponent, a to the n times b to the n. Okay, same thing as the last one, only it's a fraction. We're still going to apply the exponent to everything in the parentheses. Okay, for this one we can first flip it over. Then we can apply the exponents. Okay, if you have a problem where one of the exponents are negative or both of the exponents are negative, you can move it to the opposite part of the fraction. So a to the negative n, we can make it a to the n in the denominator. And then since the denominator fraction was also negative, we can move it to the numerator to make it positive. Okay, so a lot of times your bases aren't the same. You want to try to make them the same right away. So I would rewrite that 4 as 2 squared. Okay, because we may not be able to use a calculator for these type, I want you to understand how to do it. So power to a power, we got 2 to the negative 6th over 2 to the negative 8th. So now you can subtract those exponents. So it's going to be 2 to the negative 6th minus a negative 8. Okay, what will that end up being? Plus 2 to the 2nd, which is just 4. Okay, go ahead and pause the video. Try number 8 and 9. Okay, so number 8, the 4th root of 16, we can think of 16 as 2 times 2 times 2 times 2. So the 4th root of 2 to the 4th, and then those will cancel just to be 2. Another way you can think of writing them with rational exponents. So 2 to the 4th over 4, which equals 2 to the 1st, or just 2. Okay, number 9. Make sure you apply those exponents. 1 to the 4th is still 1. This one was a negative exponent, so first of all, make it positive. Okay, and then from there, you can, I left my 3's so that I could do it kind of in my head instead of needing a calculator or having to do that much difficult calculations. So we have 3 squared and 3 to the 4th. We can simplify that to be 3 squared in the denominator and times 7 squared, which was 49 times 9, 1 over 441. All right, for the square roots, you can simplify right away if you want. 132 divided by 3, square root of it all. Same thing with 11. We can multiply right away. So we would get 132 divided by 3 would be 44. Well, now I can break that apart. So I can break it apart to be square root of 4 and square root of 11. So then my answer would be 2 times the square root of 11. For number 11, I can simplify 32 times 2 to be 64. What times what times what is 64? So 64 is the same thing as 4 to the 3rd. So then the cubed root of 64 is just 4. All right. These are similar to the ones that we did last week, so maybe pause your video, see if you can try them on your own. Okay, for number 12, it may be helpful to leave those 3's as the bases and don't actually multiply it out, because I can't do 3 to the 6th in my head real quick. So if you can use some other techniques, you can do stuff in your head. So then keep working through from there. We want to combine the a's. So we have an a squared and an a to the 3rd. So since they're all being on the numerators, they're all being multiplied. So it becomes a to the 5th. Okay, I have a b to the 4th on the numerator and b to the 2nd on the denominator. So those I'm going to subtract to get b squared in the numerator since the 4 was bigger. And then for the 3's, we'll get 3 to the 6th and 3 to the 2nd. So we can subtract those to get 3 to the 4th. So then finally, what is 3 to the 4th? 3 times 3 times 3 times 3 would be 81. A to the 5th, B to the 2nd. All right. Go ahead and try 13. You can pause the video there. All right, don't forget to apply the exponent to the 8. Once you get there, you can simplify the 64 and the 16. That's just a fraction. So 64 over 16 is just going to be 4 in the numerator. The x's, x to the 6th and x to the 6th will cancel. So we'll just be left with 4y to the 4th. Okay, over 1, or you don't need to write the denominator. All right, go ahead and try 14. All right, so for fractions, once you get them simplified, go ahead and multiply straight across. So a to the 3rd, b squared times b squared would end up being b to the 4th. You're going to add those. And then for the denominator, we have a to the 1st and a to the 8th. Add those to be a to the 9th, b to the 4th. And we can simplify a to the 3rd over a to the 9th. So the bigger one was on the denominator. So we're going to subtract still, but put the answer where the bigger exponent started. And then b to the 4th over b to the 4th, that'll just be a 1. So it's going to be 1 over a to the 6th. All right, go ahead and try 15. All right, to finish up number 15 there, you want to first flip the fraction to make it a positive second power, then apply the exponent. Don't forget to apply it to the 3, so it'll become 9. And then I just kind of color-coded, put the x's together, so you have an x on the numerator, x in the denominator, so subtract the exponents, should stay in the denominator. Do the z's, do the y's, okay? All right, so your assignment is from your textbook, and this is 1.2 part 1. Page 22, numbers 10, 12, 16, 18, 22, 26, 30, 34 through 44 evens. All right, we'll see you tomorrow.